Hey, welcome back. Okay, so in this video, we're going to talk about generators, and in particular, I'm going to show you how to make an infinite generator, which maybe isn't that common, but I want to show it to you because it's something that we can only really do with iterators. So for example, I kind of thought for a long time about an example that would potentially make sense. Let's say that I'm making a music application, like I'm a DJ, and I want some sort of software written in Python that helps me create, sounds and play sounds on certain beats. And for our example, we're going to work in 4/4 time, which if you're not a musician, basically just 4 beats to a measure. It's a classic rock and roll counting, 1, 2, 3, 4, 1, 2, 3, 4. Anyway, what we're going to do is create a function. And let's say I want a function called current beat. And it always gives me the current beat, either 1, 2, 3, or 4. And then it starts at 1, then 2, then 3, then 4, and then next time it goes back to 1. And it just helps me figure out where I am in the music, what beat in a measure. And if none of that makes sense, let's just say I want a function that just returns 1, 2, 3, 4, and then cycles back to 1, 2, 3, 4. But I don't want them all at once. I want the current beat each time. I want 1. I want 2. For example, I could have a function called play kick drum. Let's say I'm trying to mimic Queen's We Will Rock You. There's a classic drum pattern where the kick drum plays on the first and second beat and then not on the third and fourth. So then we get 1, 2, 3, 4. And I only want that sound to play, if current beat is equal to 1, calling current beat. Then we'll play sound or something. Of course, this code won't work. We don't have any audio set up. But if this is what we had, current beat needs to reliably return 1, 2, 3, or 4, and then repeat. Okay, all that is just setup for what I'm trying to show you. If we defined a function called current beat, how could we have it return a single number, but every time return a different number, and then start repeating? We don't have a way of doing that. We can return one thing from a function. So of course we could create a class. We could, instantiate this class like we saw earlier when we created a counter class, make it an iterator. But the point is, with just a regular function, we can't. What we could do is, return a list that we could generate. And that's less than ideal, of course, because, it's way less than ideal. I want one thing at a time, but we could have a list or a tuple of numbers. Let's say 1, 2, 3, 4. We could have an index set to 0. We could do something like set a max equal to 100, and we need one more thing, a result list or tuple, whatever, while length of result is less than max. Inside of there, what we're going to do is basically take nums of I starting at 0. We'll add 1 to I plus equals 1. And we'll append that to result.append nums I plus equals 1, but we will run into a problem when I gets past the length of the list. So we need to add an if. So if I is greater than or equal to the length of nums, so that in this case, as soon as it gets to the length 0, 1, 2, 3, then we reset it to 0. So then I goes back to 0. And then finally, we can return result. All of this is a long way to show you of something that I don't want in the limitation of function. And if I print current beat and I try running it, there we go. 1, 2, 3, 4, 1, 2, 3, 4, over and over and over, repeating in a cycle. But that is not what I want. I want one thing at a time. And let's say that I had 10,000 measures or 1,000,000 measures of music going. For this to even begin to work, I guess I could generate this first. And then I could loop through it one item at a time. But for that to begin to work, my list would have to hold, 4 million? If there's 1,000,000 measures and there's 4 beats in the measure, that means 4 million things that it's holding at once before we even begin. And that's bad because lists, as they grow, take up a lot of memory. And I only need one thing at a time. Okay, so all of this is to show you, instead, let's go this route with a generator. Current beat, and we'll have the same thing, nums. Wow, I really butchered it there. 1, 2, 3, 4. And we'll have an I set to 0. And then we'll just while true, so forever. We could start by just yielding nums of I. And so that should give us 0, and then adding 1 to I plus equals 1, just like before. But we still have that problem where if we get to the end, so we'll just do if I is greater than or equal to length of nums, I equals 0, reset it back to 0. And this will keep going every time we call next on that. And I'll just prove that and also double check if I have any errors here. Looks good. So if I just make this thing called, counter equals current beat, and I do next on counter, we get 1, then 2, and 3, 4, 1, 2, 3, and it keeps going forever. So anytime my code, whatever it is, needs next beat, it can call next on counter, and it will keep going forever. But it still only gives 1 beat at a time, so I don't have this giant list. Again, if I had a million measures, it doesn't matter how many measures I have, because all that I'm really dealing with is 1 number at a time. I think I just added a letter here accidentally. I'm dealing with 1 number at a time rather than 4 million stored in a list. So hopefully that distinction is clear. This is not really something you have to do all that often. Not just the music part, but any sort of infinite generator. But it is really cool to know that you can do this, and that I think it shows a big difference compared to a typical function. Okay, so next what I'm going to show you is how we can actually see the difference in memory usage between a generator and using a function with a list or something when we start working with like millions of results.